I'm not going to begin by trying to persuade you that programming is important. You already know this. And unlike some, I won't begin by pretending that everything about programming is always simple and easy. A lot of it is, and some of it isn't and takes time. But you already know this too. So instead, let me begin by telling you why this course is different and how it'll make learning programming, if not always easy, at least easier. You see, most people would have you jump straight into one programming language. We're not going to do that here. Instead, we will explore many different languages and use them to make sense of programming itself and what that really means. To get clear on the most important ideas, concepts, the rules that lie at the heart of all of this. So it then doesn't matter which programming language you decide to dive into, they all make sense. So we'll cover the terminology, the jargon, the words we use every day in programming, terms like algorithms, recursion, object orientation, static typing, pseudocode, multi-threading, and lots more. But it's not just to be able to talk like a programmer. More than that, you'll understand the meaning behind those words. So when you want to, you can think like a programmer. And there is huge flexibility in that thinking. Programming is not one thing. It is not fixed. It is different for different people. For some, programming is corporate. It's all business. For others, programming is game development, or it's art, or music, or language, or telling a robotic arm how to deal cards. We're taking this infinitely reconfigurable machine, one that can be different from moment to moment, and turning it into the machine that does what we want it to do. And to be able to do this, to have an idea in our head and turn it into a computer program, it's not about what language you use or what operating system you have. It is about how you think. You could take this course for a lot of different reasons. Let's quickly cover 3 of them. First, you want to become a programmer, a software developer. If you want to build programs for a desktop or laptop, for the web, for a phone, whether it's Mac or Windows or Linux or whatever else may come in the future, what we're covering here are the core ideas and skills you will always need and always come back to. Reason number 2, you may have no intention of becoming a programmer right now, but you do work with them or manage them or live with one, and you've been thinking it might be useful to know more about their world and what's important to them. Maybe just get a better idea of what exactly does a programmer actually do all day long. You'll get that here. And reason number 3. What if you're not completely sure about this? Perhaps you're worried this might not be for you. Or maybe it's too late. Maybe if you were wired up the right way, surely you would have done this already. No, it's okay. Programming doesn't have to be the grand passion of your life. Now, if it is, fantastic. But right now, I don't even need you to be totally sure about what you plan to do with this knowledge. But is there something about this you find interesting? That's good enough. We can work with that. When you read about this or see it on films or TV, is there something about programming and coding that looks interesting or a little intriguing? Now, it might also sometimes look a bit intimidating or unfriendly or frustrating or boring. Sure, it can be those things. For some people, it's just a job. But this can also be incredibly rewarding, both intellectually and in your career. Whatever background you're coming from, I guarantee you that learning more about this is always worth it. To learn anything well, we should always be unashamed to ask even the most basic question. So, what is a computer program? Okay, I get it. That sounds too easy. I could take a room full of random people and ask, what is a computer program? And I will get answers, the things everybody kind of knows, like,
a computer program is a way to tell a computer what to do.
That's true, but useless. It doesn't help us here. Or I'll get,
a computer program is a list of instructions.
Also true, and a bit more specific, but still not very helpful. What does this really mean? What kind of instructions would be in such a list? What do they look like? How do you tell a computer to do something, and what can you actually tell it to do? Now, sure, it would be great if we could actually just talk to it. Make an interesting naval strategy game set in the Napoleonic Wars. But as you can guess, our instructions need to be a little more specific than that. Now, before I show you some, I will admit that if you take them one by one, the instructions we can use in a computer program are going to seem a little simple, unremarkable, unimpressive, a bit dull, because they're simple things like add one number to another number. That's the kind of thing we can actually ask a computer to do. Add one number to another number. Or display the word hello on the screen, or beep for 1/2 of a second. These are specific, self-contained, and very small instructions. Now, many people have heard this, but they don't want to admit there's something unsatisfying about the idea of computer programs just being a collection of teeny tiny instructions. It doesn't feel like a good enough answer. Here's what I mean. If you've ever tried one of these many Learn to Code interactive programming tutorials on the web, they'll usually have you begin by typing one of these simple instructions. Whether you're trying to learn the language JavaScript or Swift or Python, doesn't matter. What they ask you to type will usually look something like this. It's one instruction to the computer to display some text on the screen. You can use this one instruction to make a program, what's often called a Hello World computer program. That's a program that just does one very basic thing to prove that it works. So you write this, you learn how to run or execute your new computer program, and you get your result. And you wonder if you're supposed to feel like a programmer now, but then you look at the kind of thing you actually like to do on your computer. And this does not feel like the same thing as this. So I forgive anyone for thinking, okay, I can understand how this happens, but there's no way this is just a list of instructions like add one number to another number. But it is. It really is. As we'll see, all computer programs are constructed from multiple small, specific, individual instructions. As one equivalent, think of a recipe in a cookbook, because that's also a list of instructions. It's a series of steps to follow to make one dish. And it doesn't matter if that recipe is short and simple or long and difficult. They all come down to specific, well-defined instructions like add 1/4 teaspoon salt or heat oven to 220 degrees. And by itself, as in programming, each individual step is kind of boring. And looking at one instruction by itself tells us nothing. This one instruction here could be used to make a cake, but it could also be part of a huge multi-day preparation of a 12-course state banquet for 100 people involving truffled quail jelly and live lobsters. In cooking and in programming, if you want impressive, complicated results, you will still use basic, simple instructions. You will just have a lot more of them. Even when you understand this fact intellectually, there's often part of your brain thinking, yep, I don't see how we get from Hello World to Hello World of Warcraft. And it's okay if that's not apparent yet. That's why we're doing this. But we start simple. We have to start with the programming equivalent of how to boil an egg, because even if it's unexciting, it's how we get the first ideas into our bones. Idea number one, in programming, we build incredibly complex results from combining lots of simple instructions. And idea number two is that the order of those instructions is incredibly important. So imagine we're following a basic recipe with just 10 or 12 steps to it. It's simple enough, but if we take just 2 of these steps, where we add 4 eggs and combine, and then bake for 40 minutes at 350 degrees, you don't change anything about these instructions, you just put them the wrong way around. Bake for 40 minutes, then add 4 raw eggs and combine. One result is going on a plate, and the other is going in the garbage. So even though each instruction, each step might be well defined, they're also often dependent on each other, and the right sequence is the difference between a result that works and a result that doesn't. So if you understand the idea that to write a recipe, one that other people could follow reliably, you would have to think it through. You'd have to focus on exact quantities. You'd have to break it into small steps and have those steps in the right order. And you'd probably have someone test it to make sure you didn't forget something. And it's the same process we need in programming. To think through a larger idea, break it into small steps, those individual instructions, make sure the amounts are correct and the sequence is exact, so we can tell where we do have some flexibility about how to phrase it for human beings to understand. We must now write our instructions in a way that the computer understands, using a programming language. And we have a lot of options for that, so let's see a few of them.